right, so we're going to go over the review worksheet, and we have getting ready for a quest over sections 11.1 to 11.5. So first of all, we started with exponents. To do number one, we're looking at kind of the exponents. The ones I'm really going to look at first are the 2 here and the 2 that are outside parentheses. So when the 2 is outside parentheses, it affects all the bases. So here I need to take x squared squared, so that turns into x to the 4th. Here I need to take y to the 2nd squared, and that turns into the y to the 4th. Here I need to take 3 squared, so that turns into 9. Here I need to take the x squared, x squared. This parenthesis doesn't have any outer exponent, and so I can just write it down. Then what I'm going to do is combine terms that are alike. So the 9 would be the only coefficient there. The x's I have to look at here, the x to the 4th, the x to the 2nd, and the x to the 1st. So that's going to give me x to the 6th, 7th here. For the y's, I'm going to look at the y to the 4th and the y to the 3rd. So that's going to give me, that's going to give me y to the 7th. And that's my final answer for simplified form of that equation. Let's look at number 2. Here it's more about, first of all, what I'd be looking at is how do I get this, make it into a positive exponent. So to make that into a positive exponent, I would put it in the numerator. So now I'd see this as 15r to the 5th, s to the 2nd, and then I'd have this s to the 4th in the numerator. So I had to make that go into the opposite part of my fraction to make it be a positive. And then I have 5r to the 5th, and that's it. Okay? So what I'm looking at here is kind of how do I think of this in terms of common basis. So my final answer, negative 15 over 5 is negative 3. The r to the 5th, and we have r to the 5th, that's just 1, so I'm not even going to write it down. And then we had s to the 6th for an answer, and that's my final answer there. Next problem, number 3. The big thing I need to deal with here is dealing with this 3 there. So to deal with the 3, I'm going to take that 3 to the 3rd power, and I got 27. The x squared to the 3rd power is x to the 6th, and we have y to the 3rd power, so I have y to the 3rd. Here I have negative 4. X to the 5th, y to the 4th. So I really didn't have to deal with anything there. I'm just looking at how do I make it into, how do I simplify at this point? So the negative 4 times positive 27 is negative 108. Then I'd have x to the 11th and y to the 7th. That is my final answer. For number 4, first thing I'm looking at here is this 3 and this 3. So I'm looking at the exponents on the outside of parentheses. 4 to the 3rd is 64. X to the 3rd, x to the 9th. Negative 4 to the 3rd is negative 64. And then we have x to the 3rd and y to the 3rd. Now my problem becomes what's 64 times a negative 64. That turns out to be a negative 4096. Now we have x to the 9th and then an x to the 3rd. That makes x to the 12th, and we have y to the 3rd. Moving on to number 5 here. Again, I'm really looking at all the exponents. So 3 to the 4th power, first of all, is 81. X to the 4th and y to the 4th. Now I'm going to write my z to the negative 4th. I have my x to the negative 2, my y to the negative 3, and my z. My step now is I'm really going to look at, okay, where do I have these negative exponents here? And I have 3 negative exponents. So I'm going to rewrite this, and I'm going to change my negative exponents into positive exponents by having them go on the opposite side of my fraction. So the x to the 4th was fine, the y to the 4th was fine. But that z to the 4th, the negative 4th, should come down to the denominator because it should be z to the positive 4th in denominator. This x to the negative 2 would become an x to the positive 2. This y to the 3rd would become a y to the positive 3. And then we had our z that was always in the denominator. So then our final answer would be 81, and it would be x to the 3rd, y to the 7th, all over z to the 5th. So now it's just about combining like terms. All right, number 6 is kind of a good challenge problem. What I did here is I said, okay, everything starts off with this negative 3. And I need to take each and every base and raise it to that negative 3 power. So what I did is I started and I said, okay, 4 to the negative 3. X to the 3rd to the negative 3. So this is what I'm kind of thinking in my head. Would be x to the negative 9th. So I'm going to write here x to the negative 9th. Y to the 3rd. Now now same type of problem, but now I have it off to the side. I have y to the negative third and then to the negative third. That actually turns out to be y to the positive ninth. Now I have 3 to the negative third, I have x to the negative 12th, I have y to the negative 9. Now I'm going to look for, okay, what do I have that's raised to a negative exponent? I'm only looking for negative exponents here. And I have 5 of them, so there's a lot of things that I need to kind of move around. So the first thing I'm going to move around, 4 to the third is going to be in the denominator, and 3 to the third would be in the numerator. So those negatives got moved. My x to the negative 9 here, I'd put in the denominator. The y to the ninth, I'm going to leave in the numerator. I already moved this one. X to the 12th would now be in the numerator, and this y to the negative 9 would be also in the numerator. Okay? Combining or simplifying at this point, 3 to the third is 27. 4 to the third, sorry, is 64. Right here, when I'm looking at this and saying, okay, how can I simplify x to the 12th over x to the 9th? It turns out to be x to the third in the numerator. Next thing I need to simplify are these two y to the 9ths, and that would be y to the 18th in the numerator. This is actually my final answer. I guess I didn't circle this final answer. Let's keep going. Now we're going to look here at number 7. This is a good one because it's the difference between a negative coefficient and a negative exponent. Two very different things. So the first thing I'd start here is I take 3 squared and I got 9. I took c squared and squared it. I got c to the 4th. Then this negative d to the 5th is a negative d, and then to the 5th power, there's still a negative for this d. What I did with the negative is I brought it out in front of the whole fraction because I think that really helps us to remind ourselves that negative is there. If I put it with the d, I usually kind of forget about it, and so I usually put it out in front. Then I had this negative 45, I had c to the 7th, and d to the 3rd. So what I'm doing now is I'm kind of thinking to myself, okay, let's put it into categories. How do I reduce negative 9 over negative 45? And the answer is I have a 5 in the denominator. How do I reduce c to the 4th over c to the 7th? It's c to the 3rd in the denominator. Then how do I reduce d to the 5th and d to the 3rd? It turns out to d to the 2nd in the numerator. This is here my answer. So that's my final answer, d squared over 5c to the 3rd. For 8, anything raised to the 0 power is going to be 1. For 9, it's really a matter of seeing it as base s's and constants. And how do we reduce? The fact that we have a negative 24 doesn't move anything because it's the coefficient that's negative, not the exponent. So my answer here would be a negative in front of everything, and then we have a 12, and then it would be s to the 3rd. And actually that is reduced. It'd be over 1, which we would just leave it as negative 12s to the 3rd. Here, let's simplify. Negative 2 squared, now that's a positive 4. So when you raise a negative number to an even power, it becomes positive. T is to the 6th power. All right, right here, then we have another t. This time it's to the 2nd power. So this right here, we're multiplying these two exponents. Negative 2 times negative 1 is positive 2. And then in the denominator, we'd have t to the negative 6. Well, now I need to move this denominator. Okay, so now in the numerator I have my 4, my t, and my t to the 6, excuse me, and t second. And now in the numerator I'm going to have another t to the, sorry, and I have the wrong number here, t to the 6th. Okay, which means in the end my answer is going to be 4t to the 14th. And that is my final answer. Let's keep moving. All right, now we have our word problems. I think we'll be able to get through our word problems. We're going to have to probably have 2 videos for this answer key. For 11, your grandma bought a piano 10 years ago for $12,000. The piano depreciates by 9% each year. What would the piano be worth now, 10 years later? Well, when we have things that are depreciated, interest is collected once a year. The formula for when something is collected once a year is you take your original value and you go 1 plus the rate and then times the time. So the time is your exponent. Now here my original value was, it was worth $12,000. But the rate here, it's depreciating. Well, when a rate depreciates, you subtract the rate. So we're going to subtract 0.09 for our rate, and we were talking over a timeline of 12 years. Now when I calculated that on my calculator, I got an answer of $4,672.99, and that's how much this piano would be worth after those 10 years. Now in number 12, now we're having it compounded more than once a year. So the formula for when it's compounded for more than once a year is that the amount equals the principal, and you go 1 plus, now instead of saying the rate, you're going to say the rate divided by the number of times it's compounded in a year, and then the exponent is n times t, the number of times compounded in a year times the time it's been in there. And we're actually going to do this 2 times because we're completing this equation for 2 different scenarios, and we're saying which scenario is better. It's not the best worded question, I'll give you that, but at least we know our formulas here. So this is when it's compounded more than once in a year. This is the formula you're going to use. So in the first scenario here, we're going to have $8,000, and the rate that we're talking about is 0.06. It is a plus because we're adding to it each year. We're going to collect money every year. And the number of times, since it's semi-annually, is 2 times a year. And then we're going to take this 2 and multiply it by 7 times the 7 years. So my answer here, excuse me, when I calculated that, I got $12,100.72. On this problem, I'm taking now $10,000, so a little less money, and my rate is 4.5%, so that's 0.045, over, now when it's monthly here, it's 12 times a year that I'm looking at this, and we're doing it for 6 years. So here my value was $13,093.03. So it kind of tells us that our better investment is our second investment. And you kind of do start off with more money, but you kind of really can see the difference amount. Now, if you said, how much did you gain? You actually gain more money with this investment, but I think it talks about which would result in a greater amount of money in the end. This is my greater amount of money. So it was kind of a badly worded question. We had a lot of questions about that of how do you really answer the question that they're asking? And this is how I chose to do that. Now let's go here. Newton's law of cooling. And actually in Newton's law there's no 0 there. There was actually a mistake, and it kind of comes to a more logical question there when you do have the right formula. So I'm going to have a question where I give you a formula. So our formula is here is 0.875 and then taken to the t power. Well, t is the number of minutes that's cooling. Well, what if t here is 12? And that's what this problem is saying. Instead of a t, put in your time. We got for an answer here, it should be at a degrees of approximately, and I should do it this way, approximately 15. All right. Next one. Nick is saving for an iPad, and it costs $430. Now, his investment right now is $420. He earns this 12% interest. It's going to be for 12 years, and a really important point is it is compounded continually. Same thing as compounded continuously. Continuous compounding is used this formula. It's called the PERT formula. P times E to the exponent of RT, where P is your initial investment. So in this case, it's $420. E is the number E. Rate is your rate, 0.12. And then we're multiplying it by the number of years. So multiply it by 2 there. So in this case, after that amount of time, after my 2 years, I'm going to have the amount of money of $533.92. So the question is, do you have enough money to buy this $530 iPad? And the answer is, oh yes, we do. Stay tuned for the second video, and that'll cover problems 15 through 35.